Good morning, my fine young scientists, and welcome back. Please take out your Sun Notes worksheet and something to write with, and we'll get started right away. As a quick reminder, pause this video as needed to fill in your notes worksheet. In our last class, we learned that our solar system formed from the solar nebula. We also learned that our star, the Sun, created vast amounts of energy. Today we're going to take a closer look at the Sun's energy production, and some of the effects it has on Earth, as we study the Sun, our very own star. After this lesson, you should be able to use the terms hydrogen, helium, gravity, pressure, and nuclear fusion to write a paragraph using complete sentences to describe how the Sun produces energy, and verbally explain how sunspots and solar flares affect Earth. To begin our journey of understanding, we must begin by asking the question, what is the structure of the Sun? The Sun is the largest part of our solar system. In fact, 99% of all the matter in our solar system is found in the Sun. Now, while the Sun may look like a solid ball, it is actually composed of gas. The gases making up the Sun are held together by gravity. The figure below shows the structure of the inside of the Sun divided into layers. We'll look at these a bit closer as we progress through the lesson. The first layer of the Sun that we'll look at is the Sun's corona. The corona is the Sun's outer atmosphere. Just like Earth's atmosphere, the corona is made up of gases. Unlike Earth's atmosphere, however, the Sun's corona reaches temperatures up to 1,000,000 degrees Fahrenheit. The superheated gases in the Sun's corona are called plasma. The Sun's corona is only visible to the naked eye during a total solar eclipse. Directly below the corona is a thin layer of the Sun's atmosphere called the chromosphere, which is about 30,000 kilometers thick. Temperatures in the chromosphere range from 4,000 Kelvin near the surface and rise up to 8,000 Kelvin at the top. The word chromosphere literally means sphere of color. This is a fitting name because at higher temperatures, hydrogen in the chromosphere emits a reddish light. Which brings us to the photosphere, the layer that gives off light. Beneath the chromosphere is the photosphere, which is the part of the Sun that we can see with our naked eyes. The photosphere is the surface of the Sun. The temperature of the photosphere is around 5,500 degrees Celsius or 9,900 degrees Fahrenheit, which is much cooler than the Sun's core. Most of the light energy produced in the Sun's core escapes from the photosphere and eventually radiates away through space, some of it reaching Earth. Let's pause our notes for a moment and see what Neil deGrasse Tyson has to say about all of this, shall we?
You like crazy astronomical facts? I got one for you. The energy created in the center of the Sun takes between 10 and 100 million years to get out of the Sun. Upon exiting the Sun, it then travels the 93 million miles to Earth in 8 minutes and 20 seconds. So that was a long, hard-fought journey to reach us. Just saying. The Sun, busy at work, keeping us warm and anybody else who uses sunlight, like all the other planets of the solar system. And aliens who are possibly looking out into the galaxy, wondering if around a star that we call the Sun has a planet that might have life.
Thank you, Mr. deGrasse Tyson. There is a link to this video in descriptions below. Continuing our journey into the Sun, from the photosphere inward we come to the convective zone. Below the photosphere is the convective zone. The convective zone is the outermost layer of the solar interior. And it is here that convection currents circulate gases and heat. Please press pause on the video and take out your lab notebook and colored pencils. When you are ready, continue the video for further instructions. To complete Activity 1, you are going to watch a video. In your lab notebook, draw, color, and take all notes given in the video. Press pause as needed to complete your notes. When you have finished with Activity 1, continue this video to finish your notes worksheet. I'll press play and the video will begin.
So this is a video on the convection zone. What is it? How does it work? What's going on in there? So, convection zone is above the core and the radiation zone. It's pretty much in the middle of the sun. Above the convection zone is the photosphere, which is basically the surface of the sun that you see. Now, as far as temperature goes, convection zone right here about 2 million Kelvin, whereas the photosphere above it is about 6,000 Kelvin, and the radiation zone below it is 10 million Kelvin. So obviously the whole layer isn't 2 million Kelvin. It gets hotter as you get lower, and it gets cooler as you get higher. And in fact, that is why it is called the convection zone, because inside the convection zone, we have these convection currents going on in there. So what happens is at the bottom, it's obviously hotter, 10 million Kelvin in the radiation zone. And so the gases and some plasma in the convection zone heats up, rises to the top because hot objects are less dense. And when they hit the cooler photosphere, only 6,000 Kelvin, they cool down and sink again. Now, what does that look like on the surface of the sun? It actually makes these things called granules. So at the top of the convection zone, at the top of these convection currents, there's hot plasma rising, and you get these warmer granules on the surface of the sun. And we can actually see those, and we'll show you in a later video. So that's the convection zone. Heat transferred by convection currents makes granules on the photosphere and around 2 million Kelvin.
Moving inward through the sun from the convective zone, we move into the radiative zone. Beneath the convective zone and just above the sun's core is the radiative zone. This is the zone which transmits the sun's core energy to the upper, inner, and outer layers as radiation. Energy travels through the radiative zone in the form of electromagnetic radiation as photons. The diagram illustrates the electromagnetic spectrum, within which visible light makes up only a small percentage. From the radiative zone, we come to the center of the sun, the core. It is here that the sun makes its energy. The core is the center of the sun. This is where the sun's energy is produced. Please press pause on the video and take out your lab notebook and colored pencils. When you are ready, continue the video for further instructions. To complete Activity 2 in your lab notebook, you will draw, label, and color a diagram depicting the 5 layers of the sun. You may use the diagram from your notes worksheet as a reference, or you may conduct an internet search to find a diagram more preferable. The process that powers our sun and most other stars is nuclear fusion. Nuclear fusion is the joining together of 2 or more atomic nuclei to form 1 or more different nuclei. This process, nuclear fusion, releases vast amounts of energy. To understand nuclear fusion, you must know a little bit about the structure of atoms. Remember that all matter is made of atoms, and that atoms are made of even smaller particles called electrons, protons, and neutrons. Protons and neutrons make up the nucleus, plural, nuclei, of the atom, and the electrons move around the nucleus. Protons have a positive charge. Neutrons have a neutral charge. And electrons have a negative charge. The diagram on your notes shows a hydrogen atom. Notice there's 1 proton in its nucleus, and 1 electron orbiting around it. Please press pause on the video and take out your lab notebook and colored pencils. When you are ready, continue the video for further instructions. To complete Activity 3, you will draw and label a hydrogen atom in your lab notebook. Be sure to provide a key, identifying the charge of each particle. When you have finished your drawing, continue the video to complete your notes worksheet. The number of protons in an atom determines which element the atom is. For example, all atoms with only 1 proton are atoms of the element hydrogen. Another example is helium. All atoms with 2 protons are atoms of helium. The number of protons found in atoms of each element are depicted in the periodic table of elements by their atomic number, as shown below. We'll close out part 1 of our notes with a short video. Be sure to watch this video, there will be information that you need for your upcoming quiz.
If we could open up the sun, we'd see layers of dense hydrogen gas, hundreds of thousands of miles deep. And at its center, the core, the sun gives birth to light. Forged in one of the most violent reactions in the universe, nuclear fusion.
The specific nuclear reaction that powers the sun is fusion. Fusion of hydrogen into helium. You take 2 hydrogen atoms, you ram them together, and what's left over is a helium atom.
It sounds simple enough, but it's not.
It's actually hard to get 2 atoms to fuse. 2 protons have the same charge, they're both positively charged, they want to repel each other.
Protons don't like to get close together. They have to come together with a huge amount of energy or velocity to get close enough to begin to fuse, and that's very, very rare.
To force protons together takes immense amounts of heat and pressure, generated by the invisible hand of gravity. The sun contains 99.8% of all the matter in the solar system. That's a lot of mass. All that mass pulls the sun together with unimaginable gravitational force.
But with gravity crushing things down, things get close enough together and nuclear fusion happens.
In this nuclear compactor, hydrogen atoms slam together 100 million quadrillion times each second. Some of these collisions are so powerful that atoms fuse, releasing energy.
When the protons come together, to bind together, they lose a little bit of mass, and that mass gets converted into energy. And every second of every day, about 5 million tons of stuff is being converted to energy. It's amazing.
That closes us out for today. Be safe, make good choices, and I'll see you all next time.